What's up, YouTube? Well, today I'm just going to give you all a basic overview of my system, its components, and how it's wired and everything, and just give you some information on what it is and what it can do. So here we go. First off, I'm just going to start with the batteries. These are four 220 amp hour batteries at 12 volts a piece. I have them wired in parallel, so that's positive to positive, negative to negative, and so yeah, they're wired like that. And right here we have our Victron energy inverter. It is a 1200 watt 12 volt 50 amp charger, and basically it is an inverter and a charger at the exact same time. So what it does is if there's no power, or if it's at night, I use my batteries, my battery power, to charge up to run things in the house and everything. And then if my batteries are low, or the generator's on, or I just need to charge them up, I can turn on this switch right here, and this is a lightning protector, and then power will go up into the inverter. Then any loads, lights, TVs, fans and stuff will be diverted from the batteries to the power. And then these cables, instead of supplying the inverter, will be supplied by charging. So that way they can charge up their battery. The batteries can be charged up. So pretty cool. It has a switch that transfers the loads. It's around 1200ths of a second. So you're watching TV, the TV won't even flicker or anything. You won't even know, unless you might hear the click. It has a click to it, but yeah, nothing in your house will be affected by that switch over. So yeah, that's my inverter. Right here we have our solar controller, which limits the amount of power that can go to our batteries. So when they're full, it chops them off, and it just helps you keep your batteries set and stable. Right now we're at 100%. That is an inaccurate reading, because this is a state. It's set on a state of charge, or SOC, which basically means it's calculating how much is going in and how much is going out. But as you can see here, my output, there's nothing hooked up. So I'm taking out power with my inverter through my battery bank, but it doesn't know that, because they're not connected, because it only has like 10mm cables, and these things right here are like 35, so that would never work. But anyway, so yeah, so that's why that's always at 100%. My batteries are at 12.7, which is also incorrect, because they're charging at the moment, and while the controller is receiving power from the sun, it's not accurate. I don't exactly know why, but at night when there's no power coming in, it's a lot more accurate. And I have another multimeter tester to check that out. Anyway, so right now we're receiving 19.8 amps from the panels. We are putting in 19.5 actually into the batteries. As the batteries get full, this number will reduce to the amount that's coming in, because the batteries are full and it's limiting the amount of power that can go into them. This is how much power is going to our output, which, as y'all can see, is nothing. So 0, 0 there. We've currently received 8 amp hours of power from the panel, which is also well, it's not incorrect. I just reset it because I left it for 4 days and it was like 600 or something. So it wasn't an accurate reading for y'all, so that's why it's only at 8. 0 amp hours to our DC loads, or our output, which, since I'm not using it, will always be 0, and then back to 100%. So that's how that works. Back down to our inverter here. This is our output. It runs up the wall, down here on the side, up to this double socket, and right here I got my kilowatt meter. So right now it says it's 6 o'clock, 8 o'clock military time, but that's just because I set it at that time, but it's really not. It's midday. We're currently pulling 90, 97, 90, something around 90 watts. We're at 128 volts, 0.45 amps, volt amps, power factor, hertz, low, high watts. We've been running it for 6 hours and 19 minutes. So we've currently been using 362 watt hours That's our euros. You can set the euros, tell you how much power you've made or used. This thing will work both ways, so yeah. But and that's just the euros thing. Yeah, but no big deal. Cool. So back to zero again. So basically, this plug runs up the wall, up in the ceiling, and then it goes over to our breaker box or fuse box. You see this red wire right here. This runs down to our power bar and supplies power to all these breakers, which are all the ones in the house. We're currently running all of our sockets, lights. We have a couple sockets in the house, which are these right here that run big things: coffee maker, iron, hot water heaters. We don't actually run off a socket, but these are the big things we cannot run off the inverter. And yeah, also this wire right here is my common, which runs to all the commons, because common is common with everyone. So that is from my inverter. So here's the black and the red, and then back here through all these is my you can't see it very well, but that's my ground. Probably it's actually this one right here. That's my ground. So yeah, this thing has been ripped apart. It's melted a couple times. I've had to rebuild it, but I just need to get the right components and switch and face and everything and put this thing back together. But that's why it looks like a mess. But this right here is our disconnect. So in the up position, which it's in right now, is the main grid, and then down here is our generator. So even though the power is on, indicated by this little red light here, it could go off any minute. It might not come back on for another 6 months. So anyway, but yeah, if we need to run hot water heaters, washing machine, bigger stuff, we will turn on the generator, and you just basically pull this down, and it won't run anything now because obviously the generator's not on. So that's your neutral, and then back up to town power. So pretty cool. I'll probably do another video on that and all the fun things that's worth. But anyway, this just disconnects these 3 breakers right here, which run the big things: hot water heater. Yeah, we have 2 hot water heaters, washing machine, coffee maker, just the big stuff. But yeah, let's go outside real quick and look at our panels and get you an overview on those. What's up? Alright, as you can see, it's pretty bright today. Got a couple clouds, but no big deal. Up there I've got 2 125s and 1 120 watt panels. Combined at full capacity, they could produce 370 watts of power at 12 volts. They're wired in parallel, positive to positive, negative to negative. So just like the batteries, same voltage all the way through. You might see they are at quite of a level. They're quite level. If looking at an angle, I really would like to change that. That's just another project thing to do. But this frame was built for another house, and they were really good at that place. But this is a different roof, different angle, so I need to get a hacksaw and rebuild it a little bit so it's a little bit more of a flat angle. But anyway, leave your questions or comments. Please subscribe. I'm going to be putting up a lot more videos. Finally got the courage to put up some videos and stuff, and it's been awesome to see other people's stuff and their systems. That's been a big encouragement, and I've learned a ton. So thank y'all, all those people who do that. And I'm just wanting to join y'all in doing this. So subscribe, ask questions, give suggestions, and I'll see what we can do. Thanks y'all. Next time.